Why do we ground? Basically for human safety. And then protect the equipment from fault currents so that if you have a fault, it can travel as fast as it needs to be to get to ground. Once it's at ground, it dissipates into the earth. And if you don't have that ground location in earth, the stray voltage destroys a lot of equipment and it can actually harm human life. What do we gain by a ground? Basically, it's protecting yourself is probably the biggest thing. Protecting human life, and then the secondary is protecting your equipment. A ground grid has a path that's continuous and permanent, ample capacity, low resistance. Circuit parts are bonded together. Bonding together is that all of them have the same ground point. It's counterproductive if you have one ground rod for one cabinet, another ground rod for another cabinet. You want to be able to have it all go to one location. Here's an example of an industry that really does a good job of grounding. And this is the telecommunication, whether it be for a cell tower or a central office. They are very thorough on their grounding. You can see that they use like a halo ground going around the top for static discharge. They got a ground grid that's in the floor. Fence is grounded. There's a big loop that goes around. It's one industry, along with a datacom, computer servers, that they really do a good job of grounding. Burndy offers 3 different types of grounding methods. First one is mechanical. That's where you would tighten it with a wrench. Should be torqued tight. All of our connectors offer a torque value. When you tighten something, especially a mechanical electrical connection, that is the weakest link of the whole wiring system, is where that is terminated. And that's where we see most of our failures. It can be over-torqued or under-torqued. It's going to cause you problems with overheating at a connection. Mechanical connectors do not fall into the category of being irreversible. Irreversible meaning that when I put a mechanical connector on, there's always the possibility that someone can come by and loosen that up. Or through vibration, it could loosen up. And most specs are written irreversible, and that means that you can either use exothermic or compression, that mechanical connectors do not fall into that category. As you can see, that a lot of the grounding in the mechanical area is for like fence post or for pipes. It's range taking, no expensive tools, it's removable, and it keeps the cost down. You're just using bolts and hardware to bind or to actually hold a conductor onto something. Exothermic is a process where they use molds. These are carbon molds, and it's 6 different alloys that are poured into the mold, ignited, and it reaches about 4,000 degrees heat in a matter of seconds. Finished product is metal that actually is liquid, flows over the cables to bond everything together. Again, this is an irreversible connection. Somebody can't tamper with it. Vibration doesn't affect it. Moisture doesn't affect that. It can be buried in earth or in concrete. What we're going to do next is an exothermic weld using a T connector with a carbon mold that'll allow a run cable and then to tap off. This would be considered our run cable, and we're going to tap off to another location. We're going to first clean the mold, and we use a soft bristle brush so that we don't damage the carbon mold. If we were to use a wire brush, we would actually take material away from the mold and would cause the mold to start leaking and wearing out. So we want to clean all the areas that we can. Next thing, we'll open our clamps so that we can position our cables. This one I'm going to actually have two different cables meeting in the center and then one tapping off. And you don't want to have them perfectly touching because we want to have the molten metal fuse between. So I'm pushing it in until it touches and then backing it off at about 1/4 inch. The next thing we do is place the steel washer. So again, I got the cables lined up. I cleaned the mold. I got the steel washer or the steel disc in there. That's going to allow this weld metal to stack up. Pour that in there. A little bit of igniter on the bottom. Again, you got your gloves on, and we should be able to get and then once we've waited about 15 seconds, you can open the mold. Yeah, it's still red hot. Compression grounding. We're taking the copper cable and a copper connector. This copper and this connector, the exact same materials. Under a certain amount of force, when I put it into the crimping tool and I apply the 12 tons of force to encircle this connector onto this cable, two like properties under a certain amount of force blend together to become one. What's needed for doing a high ground or compression grounding connector? Proper connector, then we need a crimp tool. You do need a die-taking 12-ton crimp tool. It has to be able to take U-dies because that's how the system is set up. You cannot use a 4-point crimp tool and you cannot use a die-less crimper. You do need something that is capable of taking our U-dies. And then you need the correct die set. All of our connectors will have that information on it so that you can look at your connector, that one that was passing around, it'll probably say a U997 is the U-die needed to do that crimp. This is what you would see if we had the connection cross-section under a microscope. You can see that not everything is perfectly matched up for contact points. But now we put the Penetrox in there. That fills in all these little gaps. That's what you're gaining by having that Penetrox E in every type of compression ground connector. All the information that we had on the connection, when you get it crimped, inside the die is an embossment number, and it'll be the same number that is on the die. You're going to see that it says right here, die 997. That number has to correlate with the connector number and that die number. So then the inspector knows that the right cables are used, the right connector is used, the right die was used, and the right tonnage was applied from the crimp tool to get that embossment on there. What does it say on there for the die?
997.
Okay, then you want to make sure that you have the right die. Got to look at the die. 997. And then they slide in and lock. There's a center groove in the die that allows it to be held within the tool. And with this type of die, there is no difference between right or left. So if you want to put those in. See the button right here?
Oh, yeah.
That's what locks it. And then the other button is up here. Okay. Now you can put this in and actually hold the connector and then use the cables. That's good.
12 tons of force.
Now put one cable in and then put the other one in.
And then, let's see here.
Okay. Keep going. It'll stop at 12 tons of force. And you'll see this head flex. Did you see that?
Yeah.
Now you can try it again. It's not going to overcrimp it. It's still going to be at, do you see how that head flexed? But you can see what 12 tons of force will do to that C head. It actually makes it move. Now to release it, you hit the black button. And then you look at it to make sure that you got the embossment. What number are we looking for?
997.
Yep. And that'll verify that we used the right connector, we got the right cable sizes, we got two 4-aught cables, and we used the right die with the right tonnage to get that embossment.